Hi guys, this is our project title, which is the Interplanetary Shield Surviving Solar Flares, and we are from Group 20.
The first question is, what is the differences between particles, solar wind, and wave gamma rays? Let's begin with particles. In space, there are streams of charged particles like solar wind. These particles are made up of protons, electrons, and helium nuclei, which are emitted by the sun into the space. Solar wind have mass and electric charge, so they can interact with the magnetic field and can cause it to deflect their path. As you can see on the right picture, cosmic ray is also an example of particles, and you can see it is deflected. Solar wind have low penetrating power. This is because they have electric charge, low energy, and strong interaction with the atoms they encounter. This rapid interaction means they quickly lose energy. Now let's talk about waves, specifically gamma rays. Gamma rays are electromagnetic waves, and they are the highest energy form of light in the electromagnetic spectrum, as you can see on your right side. Gamma rays have no mass and no electric charge because they are photons. Because gamma rays are light, magnetic fields cannot deflect them. You can see how the gamma rays does not deflect on the above right picture. Gamma ray has high penetrating power because it is neutral and their interaction with matter is low, allowing them to pass through more material before being absorbed and scattered. I have also included the reference I used on the bottom of the page and some pictures that can help you understand better. That's all from me. Thank you.
Next, I would like to talk about the danger of lead war. Lead has high atomic number, which the nucleus contains 82 nucleon number. When high energy cosmic rays hit the dense lead wall, they won't stop but they bombarded. This collision shatters the lead nucleus and causes the nucleus spallation that blows up the lead atoms and release a spray of secondary particles that fly further into the ship. Nuclear spallation will cause the secondary radiation that makes the shield itself become radioactive and shower the astronauts with more harmful radiation. Therefore, the best approach is by using the water wall solution. Water has low atomic number and rich in hydrogen. Water has a good ability in energy absorption. When the cosmic rays hit the hydrogen atom, they won't cause the nuclear spallation. Instead, the hydrogen able to split the cosmic rays particles into smaller pieces, which are non-dangerous. Furthermore, hydrogen also able to stop the neutrons from striking it. Hydrogen slow down and absorb the neutrons, therefore it can reduce the amount of dangerous byproducts. Lastly, water, unlike the heavier elements, they serve as the dual purpose. They shield the crew while providing the life support. They can also maximize the protection while the astronauts spend most of the time. To keep the astronauts safe, we are looking at how Earth protects itself. The core principle here is the Lorentz force, expressed by the formula F equals to Q times the cross product of V and B. Essentially, when charged particles from solar radiation hit a magnetic field, they experience a force that pushes them away from the spacecraft. However, a simple bar magnet won't work because radiation can spiral down the north and south poles, that creating an aurora effect right on the ship. To prevent this, we use a toroid to keep those magnetic lines closed and the crew protected. To actually move those high energy particles, we need incredible bending power that usually over 15 Tesla meters. Standard copper coils are too heavy and inefficient for this. Instead, we use superconducting magnet, which conduct electricity with zero resistance. While space is naturally cold, these magnets are delicate. If the cooling system fails, then a process called quenching, which means that the stored energy can be released almost instantly. Managing that the thermal stability is our biggest engineering hurdle. Finally, why choose magnets over thick walls? It comes down to the mass versus power trade-off. With traditional passive shielding, if you want to double the protection, you need double the wall thickness, which made the ship too heavy to launch. With active magnetic shielding, we can increase the protection by using more power rather than more weight. This makes the long duration mission to Mars or beyond much more feasible for the crew.
Finally, into question number 4, one of the biggest dangers to a Mars mission is what we call single event effect. A single high-energy solar particle can strike a microchip and flip a memory bit from 0 to 1. This is known as a single event upset, and it can corrupt navigation data and crash critical software. An even more dangerous case is single event latch-up, where the particle creates a parasitic short circuit, causing excessive current that can permanently damage the hardware. To counter this, we use triple modular redundancy, 3 identical processes run in parallel, and a voter circuit selects the majority output. This automatically ignores any faulty result. In addition, radiation-hardened hardware such as silicon on insulator chips and software memory scrubbing are used to prevent latch-ups and correct bit flips before they accumulate.